Hello everyone, so welcome back to the AVL tree series. So in this video lecture we are going to learn about AVL tree deletion. So in previous video lecture we have seen the insertion operation, right? And along with that insertion operation, in that we have seen rotations, basically four types of rotation that we have seen, that is R-R rotation, L-L rotation, R-L rotation, and L-R rotation. Those four rotations are applicable in the insertion. Now we are going to learn about how we can delete a particular node in an AVL tree. So usually the deletion of a node in an AVL tree is similar to the BST, binary search tree. So that means whatever criteria we are following in binary search tree for deletion, the same criteria we need to follow in AVL tree. That is a basic criteria that if I'll remind you again, I have already explained this in binary search tree video. Then also I'll explain you there are three possibility. One, that is a node with no child. So that means if you have a leaf node, so if you have a leaf node and if you want to delete it, you can directly delete it, no issue with that. And then you have node with one child, right? So if you have any node that you want to delete and that is having only one child, either left child or a right child, so what you can do is you can simply replace it with a parent, right? And you can delete that particular node. So that's a node with one child. And then third we have, that is node with two children. So if we have a node with two children, that means in that you need to go, there are two methods. One is in order successor method and another is in order predecessor method. So you need to find first of all in order of that, and that in a in order successor method you replace that particular node with the in order successor and delete that successor node from that tree. And if you follow the in order predecessor method, then you do the same with the predecessor value. So these three things, this is the basic criteria that you need to follow while deleting a node, right? Along with that, there are some additional things that you need to do. What are those additional things? That you need to check the balance factor after every deletion, because you simply delete a node following this one of this criteria. Out of this three, any one can be applicable. So you delete that node following that criteria, but after deleting that node, it might be possible that it creates imbalance in your AVL tree. So in that scenario, after every deletion, you need to check the balance factor. And if the balance factor is 0, 1 and -1, then as you know, there will be no issue because that is still our AVL tree. But if it is other than that, that means if it is either +2 or a -2 or anything else, that means there is an imbalance, right? So in that scenario you need to balance it, right? So here also you need to apply the rotation the similar way you applied the rotation in insertion, right? But in insertion you have basically four rotation, LL, RR, RL and LR, right? Here in this you have actually six types of rotation, but that I can bifurcate into one as a left rotation and another one is right rotation, right? So left rotation, that means all the L type of rotation where if the deleted node is on the left side of the critical node, then you can say that it's a left rotation. and if that is on the right side of the critical node, then you can say it's a right rotation, right? So in that also you have three parts, that is R0 rotation, R1 rotation, and R minus 1 rotation. Similar way, you are here, you have L0 rotation, L1 rotation, and L minus 1 rotation. So in this video lecture, we are going to learn about R0, R1, and R minus 1 rotation. So let me quickly explain you that what is that kind of rotation. So let me take one example. Suppose we have, I'm just randomly taking a tree. So as of now, suppose I'm having this 39 over here, and I can add few more, so 27 and 18. Okay, so now I quickly check the balance factor. So balance factor is 0 0, for it's a 1, 0 minus 1 minus 1, 2 minus 2, that's a 0. Right here it's a 0, 0 minus 1 minus 1, and it's a 3 minus 2, so it's 1, right? So this is my balance factor as of now. Now if I want to delete 72, right? So delete 72. Here I have intentionally taken the leaf node, otherwise like I need to follow all the stuff, right? So suppose I'm deleting 72, anything you can delete, and you need to just keep in mind these rules, right? So if I'm deleting 72, so 72 is my leaf node, right? So that a first scenario node with no child, right? So what I need to do, I can simply delete it, right? So if I delete it, what I'll have 45 over here, 63, then I have 36, then I have 39, 40 will be here, then 27 and 18. Now again, after this deletion, I need to check the balance factor. So if I check the balance factor for 63 it's a 0, for 18 it's a 0, 40 it's a 0, 27 it's a 1 minus 0, 1, 39 it's a 0 minus 1, that's a minus 1, 36 it's a 0, for 45 it's a 3 minus 1, that's a 2, and here is the problem, this 2. That means this 45 is my critical node, because now it is no longer my AVL tree. Now in that scenario, what I need to do is I need to go for any of the rotation. So first I need to check that either I need to go for the left rotation or a right rotation. So how to check that which kind of rotation I need to go? Just you need to confirm one thing, that whatever node is deleted, that is deleted on which side of your critical node, right? So here in this scenario, this 72 is deleted from the right side of your critical node. 45 is your critical node, and previously it was here somewhere, right here. So it is deleted from the right side of my critical node. So that assures me that it will be a right rotation, right? Now in a right rotation also I am having three types of rotation. I am having R0, I am having R1, and I am having R minus 1. So what you need to do is you need to just check the critical node's opposite child's balance factor. Here the node 72 is deleted from the right side of critical node. So you need to check the left child's balance factor of the critical node. Here 36 is the left child. is 36 and 36 balance factor is 0. That means it will give me that confirmation that it would be a R0 rotation, right? So here we come to this decision that I need to do R0 rotation, right? I hope you understood this, that how we get that it's a R0 rotation, right? First what you need to check that from which side of your critical node that particular node is deleted, right? So that will give you that either it is a left rotation or a right rotation. Now from that right rotation you have three options: 0, 1 and -1, R0, R1, R minus 1. So you need to check that critical nodes left child's balance factor. Here critical nodes left child balance factor is 0. That's why it's a R0 rotation. You might be thinking, now this is one more new kind of rotation I need to learn, right? No, it's a very simple. I'll give you the trick. R0 rotation is nothing but it is your LL rotation, right? So LL rotation means what? You need to, whatever your critical node is, you need to rotate your critical node towards the right. That is your R0 rotation, or you can say simply LL rotation. So here your critical node is what? Critical node is 45. So you need to rotate this 45 towards the right. So if you rotate it towards the right, so 36 will become your root node, right? The left child will remain same, 27 and 18, and 36 right child, previously it was 39, but after rotation 45 will be taking the place of 39, right? So 36 right child will be 45, right? And 45's right child as it is 63. Now what about, you might be thinking, what about this 39, right? So I told you in earlier lecture as well, in that LL rotation also I told you that in such scenario, if it is already having a right child and after rotation that critical node is taking the place of a right child, so earlier right child will will become the left child of your critical node. So here 45 is your critical node, so 39 will become left child of your critical node, right? And 40 will remain same, so 40 will become the right child, it will remain same, it will be the right child of 39. Now if you check the balance factor, so for 18 it's a 0, for 40 it's a 0, for 63 it's a 0, for 39 it's a 0 minus 1, so minus 1, for 27 it's a 1 minus 0, 1, for 45 it's a 2 minus 1, that's a 1, for 36 it's a 2 minus 3, so it would be minus 1. Now if you check, that satisfied the condition of 0, 1, minus 1. So this is your balance AVL tree, right? So I hope you understood this. So this is your R0 rotation, right? Now you might be thinking, yeah, this is R0 rotation, then what about R1 and what about R minus 1, right? So again the simple thing, I told you how to decide it, right? If in this scenario its siblings balance factor is 0, that means I can say it's a R0 rotation, right? If its siblings balance factor if it is 1, then it would be R1 rotation. If the siblings balance factor is -1, then it would be R minus 1 rotation. I'll quickly explain you R1 and R minus 1 rotation with example. So let me take one more example. So suppose again I'm taking the same values. So that is 45 and 36, a bit of difference, right? So 45, 36, 27, 18, 39, 63 and 72. Now the balance factor of 72, it's a 0. For 18 it's a 0. For 39 it's a 0. For 27 it's a 1 minus 0, so 1. For 36 it's a 2 minus 1, so 1. For 63 it's a 0 minus 1, so minus 1. And for 45 it's a 3 minus 2, so 1. Now as of now it's your balance tree, right? So it's your AVL tree. Now again I'll delete 72 only, right? So if I delete 72, so I'll be having something like this, 45 and then 36 and then 63, then here 27 and here 18 and here 39. Now if I check the balance factor, here it's a 0 0 0 1, 2 minus 1 again 1, and 3 minus 1, that's a 2, right? So here your critical node is again 45, right? 45 is your critical node. What you need to check, that from which side of critical node it is deleted. So again it's the same side, right side, right? So you can know that it's a R type of rotation. Now which one, R0, R1 or R minus 1, right? So you just need to check the balance factor of critical nodes left child, that is 36 here. 36 balance factor is 1, so it will be R1 kind of rotation, right? Now what is the difference between R0 and R1, you might be thinking, because I told you R0 is nothing but LL rotation, right? Similar, R1 is also same, LL rotation, right? So again you need to do the same thing. You need to rotate your critical nodes towards the right side. So if I rotate my critical node towards the right side, what I'll have 36 as my root node, right? The left side of 36 remains same, this 27, this 18, right? Now again the right side of 36 will 45 will take that place, right? 45's right side will remain same, 63. Now the previously 39 was right child of 36, so now it will become the left child of 45. So here I have 39, right? So yeah, that's it. Now if I check the balance factor, so it's a 0 0 0 0, 1 minus 0, so that's a 1, and again a 0, right? So yeah, it's a balance. It is your AVL tree. So this is your R1 rotation. Again I'll tell you, R0 and R1 both are LL rotation, right? Now I'll quickly explain you the one more, the last one, that is R minus 1 rotation, right? So what would be the R minus 1 rotation? R minus 1, again the same thing, you need to check the balance factor, right? So I'll quickly take one example, right? So I'll have 45 over here, a bit of difference from that tree only. So 36, then if I have 27 over here, then 39, then 37, 41, 63 and 72. Now if I check the balance factor, 37 it's a 0, 41 it's a 0, 72 it's a 0, 27 it's a 0. Why? Because all are leaf node, right? Now what I need to do, for 39 also it's a 0, for 36 it's a 1 minus 2, so minus 1, right? For 63 it's a 0 minus, it's a 0 minus 1, so it's a minus 1, and 2 minus 2, that's a 0, right? It's not 2 minus, it's a 3 minus 2, so it's a 1, right? So in this scenario here you have this, right? Now if I delete 72, again the same I'm deleting, right? Now if I delete 72, that means again I'll have this 45. I'll draw here only that 45, then 63, then 72, then 36, then 27, then 39, then 37 and 41. Okay, I have deleted this 72, right? Now if I check the balance factor, so for 37 it's a 0, 41 it's a 0, 39 it's a 0, 27 it's a 0, 63 it's a 0, 36 it's a 1 minus 2, so minus 1, and 45 it's like 3 minus 1, so it's 2, right? So here this 45 is your critical node, right? Now again you need to check from which side. So again it's from the right side, so you can say yeah, it's a R kind of rotation. Now which are 0 or minus 1? So here you need to check the balance factor of 45's left child, that is 36, and its balance factor is minus 1. So it's an R minus 1 kind of rotation. Now you might be thinking that R0 is LL, R1 is LL, so R minus 1 is also LL. No, it's not like that. R minus 1, that is your LR rotation, right? So in a LR rotation, first what you need to do, you need to rotate first towards the left and then towards the right. Now whom to rotate left and whom to rotate right, I told you in the previous video lecture of LR rotation. So you might be remembering that. If yes, then very good. If no, then you can go through that video lecture again. Here also I'll explain you. So what you need to do is you need to just rotate the node below the critical node towards the left, right? And then the critical node towards the right. So here the node below the critical node, that is 36. So we are going to rotate 36 towards the left, right? So the intermediate step would be 45 will be here only. Then if I rotate 36 towards left, so 39 will take place of 36. 41 will be here. 63 as it is. Then 36 will become the left child of 39, right? And 37, which was previously the left child of 39, will become the right child of 36. So 37 is here and 27 will remain same. Now this is not done. This is intermediate step only, right? So this is a middle step. Now you need to rotate your critical node. This is only first rotation, left rotation. After this you need to rotate your critical node towards the right, right? So what is your critical node? It is 45. So you need to rotate it towards the right. So if you rotate it towards the right, so 39 will become the root node. The left side of 39 will remain same. 36, 27 and 37, right? Now 45 will become right child of 39, right? 63 remain as it is. And as I told you earlier, that 41, which was previously the right child of 39, now it will become the left child of 45, right? So yeah, after this again this is done, right? This right rotation is done. So first here you did a left rotation, right? And here you did the right rotation, right? So after that again you need to check the balance factor. So 0, 0, 0, 0, this is also 0, this is also 0, and this is also 0. So this is your balance AVL tree, right? So yeah, in this lecture I have explained explained you the rotation, right? R0, R1, R minus 1 rotation, right? R0 rotation is your LL rotation, R1 rotation again it's a LL rotation, and R minus 1 rotation, that is your LR rotation. That means this both are single rotation, and this is your double rotation. So I hope you understood it, and I think from this lecture you will get an idea that what would be L0, L1 and L minus 1 rotation. Then also in next video lecture I'll explain you those L0, L1 and L minus 1 rotation. Till that, just practice this examples, because you will get better and better after practice only. So yeah, keep practicing. Thank you for watching this video.